All right, our topic for this week, we're going to be talking about calculating speed, but to go along with that, we also need to know how to calculate distance and time, and how those things are all related. So, speed, distance, and time notes. So, a definition first for distance: a measurement of length of change in position of an object. So, since the measurement of length, we're going to be looking at things that are measured in meters, feet, miles, kilometers. Any kind of one of those distance measurements can be our measurement for distance. Time is how long it takes for an event to occur. So for that, we're going to be looking at seconds, minutes, hours, those types of units for time. And then speed, another name for speed, you might see it referred to as rate, or it might ask about the rate of something. And for the rate of something, we're going to be looking at a measurement of the amount of time that it takes for an object to travel a certain distance. So if we think about speed, a lot of times people, when I ask them for a definition of speed, they say how fast something goes. So the idea, the way that you tell that something's moving faster than something else is because you're going to look at a section of that is a distance that's in front of you, and you're going to see the object go by. And the less time it takes for that object to go by, the faster it's going. So that's why when we say speed is how fast something goes, what we're really saying is it's something that's moving really fast is it's taking a short time to travel that distance, versus something that's moving slower, it's taking a longer time for it to travel that distance. So as far as calculating speed goes, speed is going to be equal to distance, which we'll label d, divided by time. So it's a ratio of distance divided by time. For speed, we can either use the letter S, or sometimes you'll see the letter R being used. Again, that would stand for rate. But to help us with that, we have what's called the speed formula triangle. And so this is something that is used for speed. You can also use this for density if you've calculated that. So maybe you've used a triangle similar to this. But the idea is this is the triangle. So the D goes on the top of the triangle, S, and then T. And what it does is it basically gives you the formula for finding either speed, distance, or time, depending on the one that you're looking for. So we're going to be looking at problems that have us calculating a variety of those things, or one of those, when we're given the other two. So the way that the formula triangle works is that if we cover up the one that we want to know, and then it shows us the relationship, or then we can find the relationship of the other two variables. And so we know that speed is equal to distance divided by time. The way the triangle shows that, and excuse my tie-dyed fingers here. So if I cover up speed, or the S in this one, then what it shows me is that I'm going to have d over t. And so d over t, I use capital letters just in the triangle that I found online, but really distance and time should be lowercase. So it shows me, again, that if I want to find speed, I cover that up, and the relationship then is d over t. For distance, when I cover up distance, I don't get s over t. This is actually s times t. So they're next to each other. So it's kind of like having parentheses around here now, where it would be one next to the other. And so to find distance, what I would do is I would take the speed, and I would multiply by the time. And then for time, if I cover time up, then covering up the t, it gives me d over s. And so if I take the distance and divide by the speed, then that's how I can find the time, if that's what I'm looking for in the problem. Okay, so now each of these things comes with units, and again, I think we're pretty familiar with distance units. You can see some examples that I have here of those. And then time units, we're pretty familiar with those. The speed units, since speed is equal to distance divided by time, then the units that we'll put on the speed are the distance units that we were given over or divided by the time units. So in this case, if I was given meters as distance, seconds as time, then my speed units would be meters per second, or meters over seconds. In math, remember the word per is equal to either divide or with a slash, right? So we say meters per second here. If I was given feet for my distance measurement, minutes for my time units, then for my speed units in that example, it would be feet per minute. If I was given kilometers as a distance unit and hours for a time unit, then my units for the speed in that problem would be kilometers, or km, over hours, or kilometers per hour. Yards and seconds would become yards per second, and miles per hour we can either write as mi over hr, or we know a common abbreviation for this one, a lot of times used in like an auto sense, is mph, right? Because that stands for miles per hour. So when you're finding a speed, or you're finding distance, or you're finding time, these are the kinds of units that you're going to want to label with. And so when you're trying to think about what labels they should go on it, if it's just a distance measure, then it should be just a distance unit. If it's just a time that you're labeling, then it should be just a time unit. If it's a speed unit, then it needs to include both the units of the distance and the time that were given in the problem, and you make a ratio out of those. Okay. All right, so now on to some examples. To help us kind of walk through these word problems that are presented with these, we're going to use a little method that I call QUES. So it's K-U-E-S, and it's a way to organize the numbers in a word problem to better understand how to solve it. So here's what it stands for. So the K stands for the knowns. Okay, so our known things. And so this could be the speed, it could be the distance, it could be the time, and so it could be any one of those. But the idea is that we're going to basically write down what numbers we know from the problem. Okay, and show what they represent. Okay, the U is for the unknown then. So what are we trying to find? Okay, is what's going to go in the U space in this. E is for the equation. Okay, so what form of the equation helps you find the unknown? And then lastly, S is kind of either stands for one of two things. So substitute slash solve. And so here's where we're going to actually put in the knowns. To the equation. And solve for unknown. Rain's really starting to pick up here in Fortuna this morning. So hopefully that's not taking away from your ability to be able to hear my explanation here. Luckily we just have 3 examples to go over now. Alright, so in this first example we're going to calculate the speed of a golf cart. So what I'm wanting to find here is kind of maybe good to highlight what you have and or some keywords from the problem when you go. So calculate the speed, so I know the speed is what I'm going to be looking for, of a golf cart that travels 140 meters in 20 seconds. Okay, so in the K part here, my knowns, I have 140 meters is one of my known numbers that I have, and since it's 140 just labeled in meters, well, if it's 140 meters, that's a amount of distance. So that's my distance in this one. So label that or show that it's equal to d. 20 seconds is the other number that I was given. and that's a measurement of time. And so if I know 140 meters and 20 seconds for my time, my unknown here then is speed. Okay, which makes sense because the speed is what I'm trying to calculate, right? It tells me to calculate speed. Now, the triangle, if we go back to having that, maybe transfer it over to this side. So again, distance is on top, speed, and then time. So remember, you can use the triangle to remember what the formulas are. So since we're wanting to find speed in this one, I cover up S. It's d over t then. So I'm going to write that here for the E part of the equation. Speed equals distance over time. And so now over here in the solving part of things, speed is going to be equal to, now substituting my numbers that I know, so my knowns go into this equation, 140 over 20. And if I divide that then, because that's what I would do with this, 140 divided by 20, I get 7. And then my units, again, this one was speed, and so the distance unit was 140 meters. The time unit was 20 seconds. That means my speed units are going to be that ratio of meters per second. Okay, so 7 meters per second for that one. Okay, number 2. The sound of thunder travels 2,000 meters. So that looks like a distance measurement, right? So that's one of my knowns. 2,000 meters is my distance. To reach you at a speed of 330 meters per second. Okay, so 330 meters per second this time is another number I'm given. And since it's meters per second, or the fact that we're told that that's a speed, that's our speed unit this time. Which means the one that we're missing is time, and it says, how far did the sound travel? Well, the answer to that would be 2,000 meters. We need to change this question. How far, or how long did it take the sound to travel? Is what the question should be, right? So we should be solving for time in this one. I'll need to go back and adjust that. So our unknown this time is t, it's the time that we should be trying to find. Okay, using our formula triangle, if I cover up the time, it's going to tell me that time is equal to distance over speed. So time is equal to distance over speed here. And now if I substitute in my knowns, my time will be equal to 2,000 meters over 330 meters per second. Okay, so I divide those. 2,000 divided by 330. Oops. Okay, and what I get is a long decimal, but notice it's a repeating pattern in there, so I could do 6.06 and then put a bar over the top. The last one there is it's just being rounded, but it would be a repeating. So 6.06, I can put a bar over the top. And now the question is, what are my units here? Well, remember, we're solving for time, and if I go back and think about the units that I was given in my problem, I had meters for my distance, and I had meters per second in my speed. So the meters in this case are going to cancel out, and the time unit then that I'm left with is the number of seconds. So I would have 6.06 bar, or you could just round it to 6.06, or you could even do 6.1, would be fine, seconds here. Alright, let's hope I got number 3 correct here in my typing out. So, if you travel, or if you drive, at an average speed of 60 miles per hour, so again that would be a speed then, so 60 miles per hour, one of my numbers, and that's a speed, to San Francisco, which is 260 miles away, so 260 miles, that's a distance. So I know a speed and a distance in this one. How long does it take to get to San Francisco? Well, I got the wording right on this one. So again, time ends up being the unknown that we're looking for here. And so time, again, either using the formula triangle, distance over speed, which means putting them in my numbers. it's 260 for the distance, which is miles over 60 miles per hour. Dividing those, 260 divided by 60 gives us 4.33, or that's 4 1/3. I could do 4.3 bar again if I wanted to and show it that way, or just round to 4.3 or 4.33. Again, it was a time that we were searching for here. If I go back to my units that were used in the problem, I had miles and then miles per hour. So the miles are actually going to cancel each other out, and I'm going to be left with a number of hours. So that's my time unit that was used in this problem. So number of hours would be 4.3 bar, or 4 1/3 hours to get to San Francisco. Now, in the set of notes, I thought I was putting one of each type of problem in here. I guess I left out a distance problem. I meant for number 2, I guess, to be a distance problem. That's why I went with how far did the sound travel, but I already gave you that. So I needed to have given you the time there. But just realize that when you do go to calculate a distance, when you do that, it's speed times time. So in that one, instead of dividing, you're actually going to need to multiply the speed times the time. Look in the worksheet for tomorrow, and you'll see some problems that do ask for distance, and I'll post my answer key for that in case you're confused on what that should look like. Okay? But that's what we're doing this week, is speed calculations.